Hello, I am Jacob Field. I'm in Calculus 1, M144 with Professor Haruda, and I have her class on Tuesdays and Thursdays from 12:45 to 2:25. This is Calculus 1 Problems for Video 2B. I want to thank you for watching. For Problem 1, we'll be finding the derivative of the following functions and showing them in unsimplified form. For Problem A, we have y equals e to the x times sine to the negative first power e to the x. The first step that we're going to do on this problem is we're going to rearrange it a little bit just so it's a little bit easier to understand. So, step 1, we're just going to rewrite it as y equals e to the x times arc sine e to the x. These are the same. We're just going to rewrite it that way to make it a little bit easier for us to visualize. Next, we're going to start y prime equals d over dx e to the x times arc sine e to the x. From here, we're going to use our differentiation. We know that these two are being multiplied together, so we're going to use our product rule. So that goes to y prime equals d over dx e to the x times arc sine e to the x plus e to the x times d over dx. Running out of room, so I'm going to push it down a little bit over here, but it's going to be arc sine e to the x. So we're going to call this h and this g. So there we see we took the derivative times the original plus the original times the derivative. That's it. That's our product rule. From here, we're just going to find the derivative. So y prime equals e to the x times arc sine e to the x plus e to the x, and then we're going to do our derivative of this right here, and that is 1 over the square root of 1 minus e to the x, all that squared, times e to the x. And that is our work for problem 1, part A. For problem 1, part B, we are given the function y equals 7x cubed times tangent to the negative first power x. We will start by rewriting this part as y equals 7x cubed times arc tan x. From here, we will start by getting the derivative, so y prime equals d over dx times 7x cubed times arc tan x. From here, we know y prime equals, we're going to split it up using our product rule just like we did in the first problem. So it's going to be d over dx 7x cubed times arctan x plus 7x cubed times d over dx of arctangent x. Okay, from here, we are going to find the derivative of these two, and that's y prime equals 21x squared, we did the derivative of this, times arctan x plus 7x cubed times 1 over 1 plus x squared. That's the derivative of arctangent x. And that's all of our work for problem 1, part B. For problem 2, we are given a word problem, and the word problem is Michio is observing a bead on a wire that is moving back and forth. Its location is given by the function s of t equals t cubed minus 24t squared plus 144t, where t is measured in seconds and position is measured in centimeters. For part A, it is asking what is the function that defines the velocity at any time. The velocity is found by taking the derivative of the original function given. So, that means that if the original function is given is s of t equals t cubed minus 24t squared plus 144t, we can find s prime of t equals 3t squared minus 48t plus 144. This is our function for velocity. For problem 2, part B, it is asking at what time does the bead stop moving. So for this, we are going to set the function that defines the velocity equal to 0. To do this, we are going to do 0 equals 3t squared minus 48t plus 144. So, start, we know what greatest common factor is 3, so we're going to put that out front. 3t squared minus 16t plus 48. So from here, since we know this, we can just cancel this because it's set to equal to 0. So 0 equals t squared minus 16t plus 48. Here, you just we're going to factor, so 0 equals t. So we know that minus 4 and minus 12 multiply to 48 and add to negative 16. So that's how we found this. And since it's set equal to 0, we can just break these apart. T minus 4 equals 0, and t minus 12 equals 0. So t equals 4 and t equals 12. So the bead stops at either at 4 seconds or at 12 seconds. For problem 2, part C, it is asking when is the bead moving forward. To start, we're going to take our velocity function that we had found, and we're going to get the derivative of this. This is the second derivative of the original function, and that is 6t minus 48. From here, we are going to find the points where the velocity was 0, and we're going to plug it into this function. So, we knew that our points were 4 and 12. Those times is when the velocity equaled 0. We found that in the last problem. So we are going to plug in s double prime of 4 equals 6 times 4 minus 48, and this results in negative 24. Since it's a negative number, we can assume that on a number line, if we were to make a number line and we add a 0.4, because this is a negative number, we can assume that it arches like this. Say we add 0.12 now. Next, we're going to do s double prime of 12 equals 6 times 12 minus 48, which equals positive 24. So here we know that it's going to be like this. If we're looking at it as parabolas, we can understand that. So therefore we know that over here is positive, it's negative here, and positive here. So we're able to find when it's moving forward, and when it's backtracking, and when it's moving forward again. This means that from time 0 to time seconds, to 4 seconds, that it is moving forward, and then from 4 seconds to 12 seconds, it is not moving forward, and then after 12 seconds again, it starts to move forward. Part 2D, it's asking to draw a simple diagram to represent the motion of the bead. So I'm going to do that here. I explained in the last problem that at time 4, it stops moving forward and starts going back till time 12, and then from time 12 and on, it keeps moving forward. So if we were to draw a diagram of how the bead is moving, it goes forward from time 0 to time 4. This is 4 seconds from 0 to 4. And then it's going to go backwards. Let's do it like that. To time, and this is at 12 seconds. It stops again. And from there on, it'll keep moving forward. So that is a diagram of the motion of the bead. For part E of problem 2, it is asking to find the total distance traveled in the first 17 seconds of the bead moving. The total distance refers to how far it traveled, whether it traveled backwards again, whether it traveled forward and then backwards and then forward. It's the distance that went forward plus the distance that went backward plus the distance that went forward again. To do this, I first plotted the original function into Desmos and made a graph, and then I was able to see from time 0 to time 4, it traveled 256 centimeters forward. From 0 to time 12, it went back the equal distance, so it went 256 centimeters forward, then 256 centimeters backward, and then to find from 12 to 17, I was able to click on the graph and you can drag up till 17. And I was able to see that it is at 425. Using what I was able to find from the graph, I was then just able to add up the 256 plus 256, because it went forward 256, then it went backward 256 centimeters, and then went forward another 425. And this equals 937 centimeters. So the total distance that the bead traveled is 937 centimeters. Problem 2, part F, it asks to find the net distance traveled in the first 17 seconds. The net distance refers to the distance it traveled from start to the end. So if it backtracks, then we deduct that. So since we know it went 256 centimeters forward, but then went 256 centimeters back, we can just cancel this, and then we're just left with the 425 that went from 12 seconds to 17 seconds. So there we can find that the net distance traveled is 425 centimeters. For problem 2, part G, it's asking what is the function that defines acceleration? We had found the function that defines velocity, so we are going to take the derivative of that function, and that will give us the function for acceleration. So we are given s prime of t equals 3t squared minus 48t plus 144. So we're going to find s double prime of t, and that's going to give us 6t minus 48. This cancels because it's a constant, and this is our function for acceleration. For problem 2, part H, it asks by hand or using a program like Desmos to sketch a graph of the position, velocity, and acceleration functions for time 0 to time 17. For this, I used Desmos, which is an online website, and I'll show you that now. As you can see here, I have the original function that we were given. Here is the function for velocity, and here is the acceleration function that we just found. And this is what they look like on a graph. This red is the original, blue is velocity, and green is acceleration. Problem 2, part I, it is asking when is the bead speeding up and when is it slowing down. For this problem, I used my graph of acceleration, and I was able to see that up until time 0 or time 8, it is negative, and after time 8, it is positive. So therefore, the particle speeds up after 8 seconds, and the particle is slowing down from 0 to 8 seconds. I want to thank you for listening to my explanation of problems for video 2B for Calculus 1 M144 with Professor Haruta. Have a good day.